Morning, students. Now I would invite Prachi ma'am to start the session.
Hello everyone, good morning. So, how are you? So, we have Bhavna and Gayatri, right? So, how are you, Bhavna and Gayatri? Okay. Also, yes. And did you try the questions that we did in the last class? Did you repeat them? Did you try them by yourself? Also, you are supposed to send the answers for the questions that I give you as a homework, right? So, yes, today in this session, we will start with the new unit, which is the atomic structure, or we say the structure of atom. So, what do you think? What are we going to learn in this unit? So, in this unit, basically, we will be learning everything about how the atoms looks like and what were the models that were given to explain the structure of an atom. So how we know atom today, like we know that it has electrons, it has a nucleus in which we have protons and the neutrons. But that was not the case, right? From the starting, there were different models that were given to explain the structure of the atom and to explain the phenomena or the reactions that were taking place or the kind of compounds that are being formed. So, in this chapter, we'll be learning about all those models, and also we will learn about the experiments that were conducted and what were some of the things which led to those particular models. And then finally, we will also learn about how do we write the electronic configuration for the elements that you see in the periodic table. So, here in this chapter, what we will learn about the discovery of electrons, protons, and neutrons. So, we will learn about the discovery of electrons, protons, and neutrons. And then, after learning that, we will learn about what were the different atomic models that were given to explain the structure of atom. So, in that, we will start with the Thomson model. And then the next model that was given for the structure of atom was the Rutherford model. And the third model that was given is the Bohr's atomic model. And after that, the final model that we use now is the quantum mechanical model. So once we will get an idea what these models are and according to them, how does an atom look like? Then we will learn about the electromagnetic radiation and Planck's quantum theory. So basically the third topic we will be learning before we will learn about the Bohr atomic model, because these were the things that led Bohr to give a model which was different from the Rutherford model. And then, as the time passed by, there were other things that were explained by the scientists. So, yes, we will be learning about those things also. So, then after that, we will learn about the photoelectric effect. And then we will see what is the de Broglie relation and Heisenberg uncertainty principle. So, once we will learn about that, then finally we will come to the quantum mechanical model. And then after learning about the quantum mechanical model, we will learn about what is the value of N, L, M, and Ms. So we will learn about the quantum numbers, and then we will learn about the atomic orbitals in the terms of quantum numbers, which is a very important part. And from here, we are going to get lot many questions in the competitive exam. So yes, this portion is very important. Which one? The quantum mechanical model, where we will be learning about the quantum numbers. And then we will see, yes, how do I fill the electrons in an atom? So for that, we will be required to learn about the various principles and the rules that we have to follow to fill the electrons in an atom. So in that, we will be learning about the Aufbau principle, Pauli's exclusion principle, and Hund's rule. And then finally, once we learn, okay, what these rules says, we will write the electronic configuration for the elements that you see in the periodic table. So these are the things that we will be learning in the structure of atom. And once we will learn all these things, we will know how the atoms look like and how are we going to fill the electrons in that particular atom. So once we learn these things, you would be able to answer the questions related to all these topics. So if this is clear to you, what are we going to learn in this particular unit? Let's quickly see what is the syllabus for JEE and NEET for this chapter, which is the atomic structure. So in atomic structure, the first thing that we will have to learn according to the syllabus is we will have to learn about the nature of electromagnetic radiation. So our learning has to start from the topic that is the nature of the electromagnetic radiation. And then it says that we have to learn about the photoelectric effect, then the spectrum of hydrogen atom, which is the part of the topic. We learn the spectrum of hydrogen atom once we will learn about the Bohr's atomic model, right? So Bohr's model of hydrogen atom, its postulates, derivation, relation for the energy, Heisenberg uncertainty principle, dual nature of matter, elementary idea of quantum mechanics, and all the things related to quantum mechanics. So as you can see that the large portion of the syllabus for the JEE and the NEET consists of the topic from the quantum mechanics, which is the quantum mechanical model of atom. So yes, we will paying a lot of attention and we will be learning that particular model in detail. So this is the syllabus for your JEE. So what we can see here is that in the syllabus, we are not required to learn about the discovery of electrons, protons, and neutrons. Also, we are not required to learn about the Thomson model and the Rutherford model. So from here, you will not be getting questions in your competitive exams, whereas your chapter has to start from the Bohr's atomic model. And as before the Bohr atomic model, we need to learn about the electromagnetic radiation and the Planck's quantum theory. But yes, today we will start from the atomic model, and there first we will learn about the Thomson model, and then we will learn about the Rutherford model and the experiment that he conducted in which he discovered the nucleus. So these are the two things that we will learn in today's session. And then in the next session, we will start with the electromagnetic radiation and the Planck quantum theory. And then finally, we will learn about the Bohr's atomic model. Now, what about the first topic, that is the discovery of the electrons, protons, and neutrons? Yes, that also we will do. Okay, but here we will start our chapter with the different atomic models, which are the Thomson model, Rutherford model, Bohr's atomic model, and quantum mechanical model. So if we take a rough look how the structure of the atom developed, right? How the structure of the atom developed. So in the previous unit, that is the some basic concepts of chemistry, we learned about the Dalton atomic theory. So where he said that the ultimate unit is the atom. So he said that, for let's suppose if I have this pen and I break it into small pieces, and I break it to a point where I'll get the smallest particle possible. So what he said is the smallest particle that I will get after breaking any compound will be a atom. So the one that I'll get in my hand will be a atom, and now we can't break this atom further, right? Which now we know, yes, obviously it was wrong, because yes, atom then further consist of the subatomic particles, which is electrons, protons, and neutrons. But at that time, he tells that the smallest particle of any substance will be a atom. That was the ultimate unit. So this is what the atom look like according to Dalton. Now, after many years came J.J. Thomson, and then he discovered electron. So he said that okay, it consisted of electrons, and obviously the atom is neutral. So if it is consisting of electron, then yes, of course, it has to be consisting of the positive charge. And then, so this model was given by J.J. Thomson. Then the certain other experiments were conducted, and the picture of the atom evolved, and then this is what we got as the picture of atom, in which we have nucleus and the electrons, they are revolving around, which is given by the Rutherford. And then came the Bohr, who said that okay, yes, we have the electrons which are revolving around the nucleus, but we have it we have these electrons at a certain energy levels. And then finally came the quantum mechanical model, in which he said that, which was given by Schrodinger. And in that, he said that yes, these electrons, they are not moving in a specific orbit. What we have is the density, or we say the cloud of electrons around the nucleus. So this is how we will move. We will move from this to this, right? So let's look at the timeline, how the things were discovered, right? So in 1897, first J.J. Thomson, so lot of experiments, they were being done with the cathode ray tubes. So people were experimenting with the cathode ray tubes, which we will learn about in the discovery of electrons. So in 1897, J.J. Thomson, he was also doing the experiment with the cathode ray tube, and in that experiment, he discovered electron. Now, once he discovered the electron, he gave a model which is known as the plum pudding model, or the raisin model, or we say the watermelon model, which you might have studied about in your lower classes also. Then, after that, in 1909, Rutherford conducted an experiment, and in that he discovered the nucleus. He discovered the nucleus, and he gave the nuclear model of atom. Nuclear model means okay, we have a certain nucleus at the center. So this model was known as the nuclear model of atom. Then after that, in 1930, Bohr came with the other model, which was different, or the improved version of the Rutherford model, based on the other observation, which included studying about the nature of the electromagnetic radiation, that is studying about the nature of light, and also the theory that was given by the Planck. So considering whatever was given by the Rutherford and considering the other experiments, then the Bohr came with the other model, which was the improved version of the Rutherford model. And this model was also known as the planetary model. Then in 1924, he explained about the wave particle duality. And then finally came the quantum mechanical model. Then finally came the quantum mechanical model, which was based on the fact that, so already when the Bohr gave model, it was known that light behaves both as particle and as the wave. Now after that, after many years, de Broglie, he said electrons also behave the same way, that they will behave both as wave and as a particle. Now, once the scientists, they know that okay, light is behaving, light has a dual nature. Also, electrons has a dual nature. So then Schrodinger, considering all what was given through these experiments, he gave the other model in which he said that the electrons, they are like a cloud around the nucleus, and the energy is quantized. So yes, we will be learning in detail what this model is all about and how it is the how we were able to overcome what was the drawbacks of the Bohr's atomic model, and then using this model, which is the quantum mechanical model, we were able to explain so many things which was not done before with the any other model that we had. So yes, in 1926 came the quantum mechanical model, and you will be surprised that after all these things were done, then at the end the discovery of neutrons happened. So yes, earlier before 1926, nobody knew about neutrons, right? Electrons were discovered, protons were discovered, but yes, the electrons were discovered in 1932 by James Chadwick. So, and then after this model in 1927, was Werner Heisenberg gave the uncertainty principle, which we are also supposed to learn. What does this principle says about an atom or about the position of electron in space? So these are all the things that we will be learning about. That is basically, as whole, we will learn how the picture of the atom developed over a period of time. So in that we will see all the different models, and basically we have to learn about the four different models. Along with that, we will learn how we are going to fill the electrons and what are the other things that contributed for these models. So I hope this is clear to you, like what are the things that we are going to learn in this particular unit. And then we will start with the first model, which is the J.J. Thomson model. So if this is clear to you, quickly type yes, and then we will move ahead with the first model, which is the J.J. Thomson model. So if this is clear, if you have the picture, if you have got the feeling, what are we going to learn in this unit? Now we will begin with learning about the various models. So let's begin with the Thomson model. So Thomson, J.J. Thomson, he was the first scientist who discovered the electron. So earlier, before this, what was not known to us is that the smallest unit is atom, right? So all the things were according to it. But once J.J. Thomson discovered the electrons, so that myth was broken. So now people knew that the smallest particle is not an atom, right? It also consisted of a subatomic particle, which is known as electron. So once he discovered the electron, what he did is he decided, okay, now I can explain how the atom is. So here we will see how the atom looks like according to J.J. Thomson. And this model is also known as the plum pudding model, or we say it is also known as raisin or watermelon model, right? You can use any of these names, which is the plum pudding, raisin, or the watermelon model. Now let's see what did he say about the atom. So what he said is that atom is a sphere. So first thing that he said is that atom is a sphere. So yes, we can imagine atom as a sphere, right? In which positive charge is uniformly distributed. What he said is that the positive charge here is uniformly distributed. So here the positive charge will be inside this sphere and it will be uniformly distributed throughout this sphere, right? So yes, this sphere, it is filled with the positive charge. So what is this? This sphere is a positive charge sphere, and that positive charge is distributed all over that sphere. So you can compare this with an watermelon. So how we can compare? So whatever the red part that you see, obviously watermelon is spherical in shape. So whatever red part that you see in the watermelon, you can imagine it as the positive charge, right? That pulp you can imagine at a like a positive charge. And what he said is that the mass of atom is assumed to be uniformly distributed over the atom. So he said that all the mass, it is uniformly distributed over the atom. It's not that, okay, some of the mass is concentrated at the center, or if the mass is concentrated at one corner. No, it is uniformly distributed over the atom, right? For example, as you see the watermelon, it's not that you have more pulp at one place, less pulp at the other place, right? There is a uniform distribution of the mass. Along with that, what he said is that the positive charge is distributed all over the atom. And with this, what he said is that the electrons, they are embedded on this, in this positive charge. As you see the seeds in the watermelon, what, how they are put? They are put in that pulp, right? Red thing, we have those electrons, so we have those seeds, so you can imagine them as electrons. So now these electrons, they are embedded on this pulp. So this is the 2D view, right? What you are seeing here, it is a 2D view. Now you can imagine it in 3D like a watermelon. So whatever red pulp you have is the positive charge, which is uniformly distributed, and in that you can imagine electrons as those seeds that you see, right? Whereas this is the 2D view, right? If I cut it, then I look at it from the front. This is how it will look like. So the electrons, they are put there into that pulp, right? So with this, he was able to explain the overall neutrality of atom. How he was able to explain that? Neutral means it is not having any overall positive or the negative charge. What we have is equal amount of positive and the negative charge. Yes, this atom explains that, right? Because what he said is we have the whole matrix, which is the positive charge, which is evenly distributed, and in that we have put the negative charge. Now that positive and negative, it will cancel out each other, and we have overall atom which is neutral. So this is the picture of atom according to the J.J. Thomson, which was a great achievement at that time, because before that nobody knew that atom consisted of the subatomic particle. Because it's a great deal to start something, right? We can make the improvement, but it's a great achievement to start something, to be a first person to discover something, right? So before this, what was known as that we consist of atom, and then we can't break atom further into smaller particles, right? But once he discovered the electrons, and then he gave this picture of atom, from here now people know that yes, the atom consists of a positive matrix. In that we have the negative charge, right? So if this is clear to you, then we will move ahead with what were the drawbacks of the Thomson model. And then finally, we will learn about the Rutherford model. So if this is clear to you, quickly type yes, and then we will see what were the drawbacks. And then we will learn about the Rutherford model. Yes. So this is how the atom looked like according to Thomson. Right? So how you can imagine it? You can imagine it as the watermelon. Right? Now, along with that, so it's not that, okay, people, Rutherford suddenly came with his model. So what happened is, so J.J. Thomson was his guide, right? Rutherford was the student of J.J. Thomson. So what he decided is, so this is the model. J.J. Thomson gave a model which was based on his experiment where he discovered the electron, right? So he conducted the experiment, he discovered the electron, and then according to his observation, he gave this model, right? Now, what Rutherford decided is, okay, I'll conduct an experiment so that I can explain this thing that we have the positive matrix and in that we have the electrons. So then he decided, okay, I'll do the experiment and then there I'll prove that, okay, the atom looks like this, which was given by J.J. Thomson. So then he decided to conduct the experiment. But what happened is when he conducted the experiment, he got something else. He was expecting observation according to the model that was given by J.J. Thomson. But once he conducted the experiment, what he observed was totally different. And then what what happened is he gave his model, right, which was different from the J.J. Thomson. So what you can see here is that he started the experiment to explain the J.J. Thomson model, but yes, after that experiment, it was proved that yes, what J.J. Thomson said was not right, and the atom is little different, or we say very different from the J.J. Thomson. So now here we will learn about what was the experiment that was conducted by the Rutherford, which proved that the J.J. Thomson model was not right, right? And with this experiment, what we can say is, so electron was discovered. Now, Rutherford, he discovered the nucleus. Rutherford, he discovered nucleus. So J.J. Thomson, he discovered electron. Then after many years, he was working under J.J. Thomson as a student, research scholar, and then he discovered the nucleus. And then once he discovered the nucleus, he gave his model, which is known as the Rutherford nuclear model of atom, because it has a nucleus. So what this model is called the nuclear model of atom. So now here we will be looking at a very famous experiment, which is the gold foil experiment, because of which we were able to know that the atom consists of nucleus. So are you ready to understand this experiment, which is the foil experiment? So quickly type yes, and then we will start learning about the gold foil experiment, because of which we were able to understand that atom consists of a nucleus. So yes. So shall we start with the gold foil experiment? So the other thing was that Rutherford, along with other scientists, were also working on the radioactive materials, right? With Curie and other scientists, he was working on the uh, those radioactive materials. So at that time, he knew about these particles, that is alpha, beta, and gamma particles. So that information he used and he made an experiment, right? So let's understand what he did in this experiment. So what he did is gold foil. So the name is gold foil. So obviously we are using a gold foil here. Where is the gold foil here? So here we have the gold foil. So what he did is he took a very thin sheet of gold, which was around 10 nanometer, very thin as possible. Because what they were trying to get is that they should just have one or two layers of atom, so that the accuracy of the experiment is maintained, right? So what he did here is that he took a source of he took a source of alpha particles. He took a source of alpha particles. And then what he did is he shot that alpha particle through this gold foil. So what he did is he took this source of alpha particle, and then he shot these alpha particle to this gold foil, right? So what are we going to get when I say alpha particles? Then it means that they are positive particles. They are positive particles. What they are? They are positive particles. So these things we will learn in radioactivity, right? About different particles, that is alpha, beta, and gamma. For now, the only thing that you should know is that when I say alpha particles, then you should know that these are the positive particles, right? So it's like shooting a gun, right? Shooting a gun at the thin sheet, for example, like shooting a gun at a tissue paper, something as thin as a tissue paper. So shooting a bullet on a tissue paper. Now, what do you think? What will happen if I'll shoot a gun at a tissue paper? So you can imagine what will happen. Or let's suppose if I take a sheet of paper, right? Sheet of paper is little thick. So tissue paper is a better example because it's very, very thin, right? So you can imagine in a larger picture how it is. Okay, so we are shooting a bullet, and then you can imagine what will happen if I shoot a gun at a tissue paper. So what will happen is that the bullets, they'll cross the tissue paper. And the same thing they were expecting from this experiment, that when I shoot these positive particles, what will happen is all of them should pass through this sheet. What they were expecting, so their expectations were, even though this is also positive, this is also positive, still they expected that these positive particles, they will come and they'll pass through this gold foil. They should pass through the atom. Why is that? Because these alpha particles, they are very, very small as compared to atom. Because basically if I look at these particles, when I say alpha particles, this is basically helium without electrons, right? Helium with two positive charge, which is not having any electrons, and we are shooting them at a very, very high speed. What I'm doing here is I'm shooting them at very, very high speed. So what they expected is, even though it is, this is positive, this is also positive, this is what Daisy Thompson said, right? That the positive charge is evenly distributed, correct? So now once they'll shoot these alpha particles with very high speed, they expected that these high moving particles, which are very small as compared to atom, will directly come and cross this sheet. Now how will they know that whatever they have shot will directly pass through this sheet? So what they have put is, they have put a detector here. What they did, they have put a detector here, and they have coated it with ZNS. So whenever any alpha particle would come, it will hit here. It will hit here, and we will see some light, right? We'll see that something is striking a fluorescence kind of thing we will see there, right? So that's how they'll know that where are these particles hitting on this screen, correct? So this was their this is their expectation. What they were expecting, that all the particles, they must pass and should hit at behind this sheet which is made up of gold, right? So this was their expectation. Now, once they conducted the experiment, that is when they started shooting these alpha particles at this gold foil. Now, what they observed is that yes, there were a large portion of the alpha particles, yes, was hitting at this screen. Yes, they can see that, they can see some fluorescence at this screen. But also what they observed is that yes, there was small portion that was hitting at these side, and a very small portion which was reflected back, reflected back at some angle, and some of it was reflected back completely at 180 degree, completely reflected back at 180 degree. So this was different from what they were expecting. This was very different from what they were expecting. They were expecting that all the particles should pass by the atom. But what they observed is, yes, the large portion of the alpha particles passed and deflected, but yes, there were certain particles which were deflected at certain angle, and some of them were deflected back completely. So this is what was happening in the experiment, right? So now we will try to understand why this was happening and what is the model that they came up with by these observations. So let's see what are their observations. So what they observed is that most of alpha particle passed through the gold foil undeflected. Yes, that was true, and this was their expectation. But what they observed is that small fraction of alpha particles was deflected by small angle. So what they mean is they were supposed to go straight, but they were deflected by very small angle. And then there were very few, that is 1 in 20,000 particles. 1 in 20,000 particles which bounced back, which bounced back, that is deflected by 180 degrees. So what happens is most of them, they were undeflected, so they have hit the screen just behind the sheet. Some of them, they deflected by a very small angle, but 1 in 20,000 alpha particle was deflected back completely by 180 degree, which was the unusual thing for them to observe. So then they came with a conclusion. So now obviously once they observed that all these things are happening, so it's required that they should explain this, right? So let's see what is the conclusion that they came up with after their observation. What was their observation? That most were deflected, some were deflected by small angle, and very few, that is 1 in 20,000 particle was completely bounced back. So now let's look at the conclusion that they came up with. So the conclusion that they made from here is, because as most of the particles went undeflected, so what they said is that the most of the space in an atom is empty as most particles were undeflected, right? And they saw that few particles, they were deflected. So from this, what they said is that deflection is due to the enormous repulsive force, showing that charge is not dispersed throughout. And what they said is that positive charge is concentrated in very small volume, right? Why did they say that? Because what they were expecting is, if the positive charge was uniformly distributed, then what should have happened is, when these particles which were moving at very high speed, they come and hit this uniformly distributed charge, what was expected is it will directly pass through this. But this was not happening, which means that whatever positive charge is there, it is concentrated at one place. Because if it is concentrated at one place, then only this can happen is, if the some positive charge, even if it is coming with the very high speed, what will happen is they'll repel each other. If it is concentrated at one place, it will happen that yes, repulsion will happen. But if it is distributed uniformly, then what will happen is that this will pass through this charge. But if it is concentrated at one place, what will be observed is that whatever positive charge will come, positive like charges, they'll repel each other. So yes, once it will face this positive charge, it has to deflect at some angle, which was observed there. So what they concluded is that, as J.J. Thomson said that this positive charge will be uniformly distributed, that was not the case. This positive charge will be concentrated at one place. And the calculation shows that volume occupied by nucleus is negligibly small. How small? So you can imagine the nucleus, if I am comparing it with the size of the atom, then if I take a cricket ball, then imagine it as a nucleus, and now the radius of the atom will be around 5 kilometers from where you are sitting, right? So let's suppose where you are sitting, imagine you are holding a cricket ball. So that will be a nucleus. Now, how big is the atom? Atom will be 5 kilometer from you, right? The radius that you have, which will make an atom, will be of 5 kilometer. Now you can imagine how big is that, right? 5 kilometer is such a long distance, correct? So what they said is that the volume that is occupied by the nucleus is negligibly small. So what we can say from here is that the nucleus is very dense. That the nucleus is very, very dense. So all the charge is concentrated at one place. And this is what was this. Now, once they know that all the charge is concentrated as one place, now this explains why some of the particles, very few, like 1 in 20,000 particle, why was it deflected or why was it bounced back? So the particle that were coming directly like this. So what will happen is, as this charge is concentrated here, what will happen? The one that will coming face to face, they will be bounced back. Whereas the one that were coming little closer, they'll be deflected at some angle. And as you know, as he said that most of the space is empty. So most of them, yes, they'll pass through the empty space. So now how does the atom look like according to Rutherford? So according to him, positive charge and most mass of atom, positive charge, and so still here also they didn't knew anything about neutrons. Now we know about positive charge, we know about the electrons. So the positive charge and most mass of the atom is densely concentrated in extremely small region. And this very small portion of atom is called nucleus. So yes, he gave the name nucleus to this, the densely concentrated charge. So the very small portion of atom where all the mass will be concentrated, that will be known as the nucleus. And here what he said is that the nucleus is surrounded by electrons. Nucleus is surrounded by electrons that move around with very high speed. So how they are moving? They are buzzing like house flies, right? They are buzzing around the nucleus in orbits, right? So it's like buzzing. They are buzzing around the nucleus. How you see the flies, right? So the nucleus is surrounded by electron that move around with very high speed. So what he said is that they are moving with very high speed in circular path called orbits. So yes, he gave the word orbits. So he gave the word nucleus, he gave the word orbit. So nucleus, according to him, is a very small portion of the atom where all the mass is concentrated at one place in a very small volume. So the small means very, very small. So it's densely concentrated, right? And the electrons, they move around the nucleus in the circular path with very high speed, and these circular paths are known as orbits. Also, what he said is that the electrons and the nucleus are held together by the electrostatic forces of attraction. That was the another addition, that the electrons and the nucleus, they are held together by the electrostatic forces of attraction. That is, I have a positive charge, I have a negative charge. So yes, two charges, point charges, they will have an electrostatic force of attraction between them. So this was the picture according to Rutherford. So how will the atom look like? So you will have a nucleus at the center which is having a positive charge, and then around them you have the electrons. So around them you have the electrons which are moving in the circular orbit. So around them you have the nucleus which are moving around. Around them you have the electrons which are moving around the nucleus. So this is how the atom looks like according to the Rutherford, which was a great improvement over the J.J. Thomson model. So till now we know that the atom, yes, it consists of, J.J. Thomson said, yes, it consisted of electron. Now we know, yes, it consisted of some positive particles also, which are concentrated at the center. So if this is clear to you, then we will see what were the drawbacks of the Rutherford model. What are the things that he was not able to explain about the atom? And then finally, in the next class, we will see what were the other experiments that led to the Bohr's atomic model. So if this is clear to you, type Y very quickly, and then we will saw the drawback. So we have to finish this portion today, which is these two models, which is J.J. Thomson, we already did. Now we will complete the Rutherford model. So what was the drawback of the Rutherford model? So he was not able to explain the stability of atom. He was not able to explain the stability of atom. Why? Because what he said is, he said that electrons and nucleus, they are held by the electrostatic force, right? So now we can't take the electrons as static, because what will happen if I take them static, then they will attract with each other and finally they will collapse with each other. So what he said is, okay, electrons, they are moving around the nucleus constantly, correct? Now, as he said that there is electrostatic force of attraction, then in physics you will learn that if I have any charged particle, then there will be coulombic forces that is acting between these atoms. Now, as these electrons, they are moving around the nucleus, what they are doing, they are moving around the nucleus. Then over a period of time, what will happen is that they will lose energy. What will happen? They will lose energy as they are charged particles. Who said that if a charged particle is moving around the nucleus and they will lose energy? Why I am saying that? How I know that? If a charged particle is moving in a circular motion around the nucleus, it will lose energy. So this was given by the Maxwell. What he said is that if any charged particle is moving in a circular path, and so what will happen is it will constantly emit radiation. And if it is emitting a radiation, what does that mean? That it will lose energy. So yes, following that, what will happen is, as the Rutherford said, yes, there is electrostatic force that is there between the nucleus and the electron. What should happen is that the electron is moving around the nucleus. Eventually, it should lose the energy and spiral and fall into the nucleus. So what should happen is, you have the nucleus, so the electron that is moving around, it should form a spiral and it must fall into the nucleus according to the laws of physics, according to the law which is given by Maxwell. But this is not the case, right? We can see, yes, we have materials around you which is consisting of atoms, right? We can see there are so many things around us. So yes, we know that atoms are stable, but this model was not able to explain the stability of atom. Now, what is the time that it will take for electron to fall into the nucleus? Just 10 raised to the power minus 8 seconds, which is a very, 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 very small amount of time. So as soon as electron is moving, it will fall into the nucleus. A spiral, lose energy, and will fall into the nucleus. So this was, so Rutherford was not able to explain this part. That is why the atom is stable. Also, he said nothing about the distribution of electrons, like how they are distributed around the nucleus, how far apart which electrons are present at the farther distance, which are the electrons that are present near to the nucleus, what is the distance, how they are distributed. All of these things are not explained by the Rutherford model. Also, he didn't say anything about the energies. So now obviously people were constantly doing the research. Scientists, they were constantly studying the atoms and they were conducting the experiments. So yes, then after this, the other model that came is the Bohr atomic model. Now, before learning about the Bohr atomic model, there are two other things which is very important for us to learn, is that is, we must be learning about the electromagnetic radiation and the Planck's quantum theory. Because after studying these theories, what they said, what was their observation, then only, so Bohr, what he did is, he studied the Rutherford model, he studied whatever it was, he studied whatever is said about the electromagnetic radiation, he studied the Planck quantum theory, and then finally he came up with his model, which is known as the Bohr atomic model. So in our next class, we'll be learning about the electromagnetic radiation and the Planck's quantum theory. So I hope this is clear to you, which is the Goyle-Fold experiment. What were the observation? So yes, you can get a direct question in your exam, in theory exam, in your board exam. That is, what is the gold foil experiment? What was its observation, conclusion, and drawbacks? Now your homework is that you have to read about the atomic number, which you have done in the lower classes also. Atomic number, mass number, isotopes, and isobars. So yes, maybe you might not have learned about isobars. Yes, obvious. For sure, we have learned about isotopes in ninth or 10th standard. So you have to read about atomic number, mass number. So yes, once these subatomic particles were discovered, so yes, we should be able to tell about the atomic number, atomic mass, how the atom is represented, which is the atomic number, which is the mass number. Now, once I know the atomic number and the mass number, will I be able to tell about the number of electrons, protons, and neutrons? And then we will see what is isotopes, isobar, and isoelectronic species. And along with that, we will be doing those other topic, that is electromagnetic radiation and Planck quantum theory, in our next class. So be present in the next class, because the topic that we will finish in the next class is very, very important. So if this is clear, if everything is clear to you, type yes. And if there is any doubt, you can ask your doubt, which I'll answer in the next class. So you can just simply type your doubt here, and I'll take that doubt in the next class. So this is all what we have learned today. That is, we saw the J.J. Thomson model, which is known as the plum pudding model. And also we saw the gold foil experiment. And in that, we saw that we learned about the Rutherford model. So if this is clear to you, then you can continue with your next class. Yes, Chandrika ma'am.
Yes, ma'am. Thank you, ma'am.
Yes. Okay, okay, thank you. Okay, see you students in the next class.
Now I would invite Kevin sir to take over.
Thank you, ma'am. I'm audible to everyone.
Yes, sir, you are audible.
So, good morning, dear students. Hello, dear students. Good morning.
Sir, they cannot unmute. You can continue,
Oh,
sir.
okay.
Yes. They are
Just a,
sending a message.
just a minute. I will share my screen. Just a minute, dear students. Ma'am, is the screen okay, ma'am? Chandrika, ma'am?
Yes, sir, it is okay. It is visible.
Not only for mobile, ma'am.
Sorry, sir.
What?
So your voice is not clear.
Okay. Is it okay, ma'am, now?
Yes, it is okay. You're
Okay,
displaying
okay.
trigonometric ratios.
Okay, okay, okay. Okay,
Yes, yes.
okay, dear students, I heard you got information that you were taught regarding the trigonometric ratios and functions. But what I will be doing is just we'll brush it up, then we'll learn the important formulas, then we'll start solving the uh, problems for our IIT level. So the most important thing that we come across trigonometric is the trigonometric ratios, which becomes a function. When we say something as a function, we already learned that a function is like a mechanism which accepts an input and gives me output. For example, if I take a, let us say our daily, if in our everyday life, if you take any electronic machine, what we do in this electronic machine, we give some input, as I said, is giving an output. For example, let us take a blender. Blender, what we do in a blender, we put some fruits or some vegetables, whatever we need, we blend it. As a result, we get respective juice or shakes. For example, if I want an apple juice, what I will do is I'll cut apple and put in a blender with some sugar or else with some sugar or else with some honey. And when I blend it, what happens? I'm getting a apple juice. It is same with regard to mango or else strawberry, any fruit. So what input I'm getting as a result of blender is blending it. It is blending it and giving me an output for juice, maybe apple juice or mango juice, etc. What if I put a stone to the blender? What if I put a stone to the blender? Will that blender work? The blender will not work. So when I say a function, functions are almost like this blender and machine. It accepts the input, does the mechanisms, and gives an output. So to say, it is almost like a machine. That is, if this is my machine, this will accept an out. It will accept an input here, does some mechanism here, and gives me an output. That is what the function is. Let it take any example in our everyday life. That's what any electronic gadget is doing this thing. It accepts some information or some kind of input and does all the mechanisms and gives us an output. Maybe a printer, a washing machine, anything. You take any example. The same thing in mathematics too. When we say about a function, the function accepts an input and as a result, it does the mechanism, does some work and gives the output. When I say a trigonometric ratios as function, we know this six trigonometric ratios, sine A or sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. These six are trigonometric ratios and how they're becoming functions, when these ratios are given some input. Let's just a minute. Now let us say I told this is my mechanism machine. I'm keeping here. So I'm putting some value here. This is my function f, or as a mechanism called sin x. The mechanism I'm doing it here is sin x. So when for this mechanism or for this machine sin x, when I give some input values or input things, the machine does some mechanisms, it works out and it gives me an output product. Let us say if I give 0 here, what happens? The mechanism makes some work, sin 0. As a result, I get an output called 0. Now we are giving an input here, something called 45 degree or as pi by 4 radians. What is happening? The machine does a work, sin 45, and I'm getting a output, a value called 1 by root 2. So in this process, what happens? When we say these 6 trigonometric ratios are functions, means all these 6 trigonometric ratios are accepting a value, a input value, and as a result of this input value, it does mechanisms and it is giving an output value. The table that you are seeing now is that is what? An acceptance of input value and a forecasting or displaying an output value. So I think already Guru sir has taken and introduced you to the concept of functions. So it will be easy for me to go on from there. So when we say a trigonometric function, it is basically an what is called as a process of accepting the input value and displaying the output value. So as a result, we get this trigonometric value table. This trigonometric value table is nothing but the mechanism of each trigonometric ratios as functions, how they have become functions. It is telling when sine is given 0 degree as input, what is the output? When sine is given 30 degree as input, what is the output? When sine is given 45 degree as input, what is the output? So the table is nothing but it is the display of how each trigonometric ratios have become function with the respective values. So just we shall quickly review the table, what this table and what the values are. So 0 degree is 0 degree, no issues. But with regard to 30 degree, how do we convert 30 degree into radians? Do you remember the formula to convert 30 degree into radians? We know that pi radians is equal to 180 degree, the relationship. So I got 30 degree. How do I convert into radians? I do what? 1 degree is equal to pi by 180. So for 30 degree, pi by 180 into 30. So this will do what? 0, 0 cancels, 3 ones are, 3 6 are. So 30 degree is my pi by 6 radians. So 30 degree is my pi by 6 radians. 45 degree, this if you do the same process, you'll get pi by 4 radians. 60 degree, it will be pi by 3 radians. And for 90 degree, it will be pi by 2 radians. So sine 0 is 0, sine pi by 6 is 1 by 2, and sine pi by 4 is 1 by root 2, sine pi by 3 is root 3 by 2, and sine 90 is 1. Once you learn this sign, it is easy to remember cos. Cos is just a reciprocal. Just sorry. Extreme sorry, just once. So once you learn this sign, cos is just a reciprocal of sine. Reciprocal means a reverse of sine. See here, if you look at very carefully the values of sine and cos, the sine value is starting from 0 and ending to 1, whereas cos value is a reverse process of sine. That is, it starts from 1 and ends to 0. 1 root 3 by 2, 1 by root 2 and 1 by 2. And remember tan it is much more easy, divide sine by cos. 0 by 1 is 0, 1 by 2 divided by root 3 by 2, 2 cancels, the rest is 1 by root 3. 1 by root 2 by 1 by root 2, numerator denominator get cancels, you have only 1. Root 3 by 2 by 1 by 2, 2 get cancels the denominator and left out is root 3. 1 by 0, any number divided by 0 is infinity, not defined. We can't define it because we know that when you say function, it should have a distinct value. So here you can't say a distinct value for the function because it's going to infinity. Therefore, we say tan pi by 2 is not defined. Whereas cosecant is just a reciprocal of sine. So whatever sine is there, we are doing it, we are reciprocal, we are what's called, we are just doing the reciprocal 1 by something. And secant also is a reciprocal of cos. So whatever cos value is there, if you write in the reciprocal form, we'll get the value of secant. And with regard to cot, it is just a reciprocal of tan. Now coming to next topic. The sign convention of or trigonometric function. So it's just a summary of what you have learned earlier. We know the angles of the quadrants. First quadrant, the angle is starting from 0 degree, and the maximum angle that we can have is 90 degree. Therefore, I can say the first quadrant angle is 90 minus theta. Means my angle can be more than 0, less than 90. Whereas my second quadrant angle starts from 90 and reaches a maximum point called 180. That means it can be more than 90 and it should be within 180. That means 90 plus theta, 180 minus theta. The third quadrant, my angle, the value of my third quadrant angle starts after 180 only. The straight line, after the straight line only, I'm starting my, what is this called as the third quadrant. Therefore, my angle is more than 190 and less than 270. Whereas in the fourth quadrant, my angle will be more than 270 and less than 360. Coming back to first quadrant now. Now we finish one circle, then our maximum value we got is 360. Let us say, and they're asking you to find the value of tan 400 degree. How do we find out? Let us go for second round. Let us take this example. Most of you have participated in the sports event, annual athletic meet, and so on. There is this track events like 1400 meters, 1800 meters, 2400 meters. So when you partake in the track event, the maximum, what is called a perimeter of a ground may be 500 meter or 600 meter for a running. Then how do you run 1400 meters and 1800 meters in that small ground? It is just taking rounds after rounds, rounds after rounds, maybe some 4 rounds or 5 rounds. So what we'll do, we complete one round, that is maybe 400 meters. When you complete second round is 800 meters. So if you want to run 1800 meters, you have to complete what is called as 4.5 rounds. So similarly here, if I want a 400 degree, I have to complete first round and I have to run little extra. So for little running extra, I have to come forward. So I am entering which quadrant again? After moving all these things, let us say, after finishing my one round, 360 is over, but my ending line is 400 meters or 400 degree. I have to move forward. I have to, let us say, for 1800 meters, if the court is 400 meters, you have to run 4 rounds. That will bring to 1600 meters. Now we have to cover another 200 meters. What you will do? From 400 meters, you will run another 200 meters. So you will reach 1800 meters. So same thing, what happens after completing a round, I want extra 40 degree to reach my 400. But then if I move forward, I'm coming and ending up in the first quadrant. So again, the first quadrant value can be increased telling 360 plus theta. So 360 plus 40 will give me 400 degree. Hope, do you understand, dear students? Continuing the same concept, we used, okay, now we learn the angles here. The main thing that we are to discuss here, which quadrant which is positive, the trigonometric functions. First quadrant, all are positive. Second quadrant, sine and cosecant are positive. Third quadrant, tan and cot are positive. Fourth quadrant, cos and secant are positive. This we call it as all silver teacups. All silver teacups. First quadrant, all the trigonometric functions are positive. Whereas the second quadrant, only the sine and cosecant will be positive. The third quadrant, only tan will be positive, that is tan in respective cot. Whereas in the fourth quadrant, cos and secant will be positive. Coming to trigonometric functions, especially with regard to ASTC rule, whenever my angle is a multiple of 90, let us say 90, 270, that is pi by 2, 3 pi by 2, 5 pi by 2. When my angle is of like this, the trigonometric function changes. It changes from sine to cos, tan to cot, cosecant to secant. Let us, I will give some example. Let us say cos pi by 2 plus theta. So pi by 2 is there. So from cos I have to change to sine. So pi by 2 plus theta is which quadrant? Pi by 2 plus theta is the second quadrant. Second quadrant, what is positive? Sine is positive, but cos is negative. So I have to put minus sine theta. Let me take one more example. Cot 3 pi by 2 minus theta. So pi by 3 pi by 2. So it is coming pi by 2 here. So what happens? I have to interchange from cot to tan. Therefore, my angle becomes, my trigonometric function becomes tan. So 3 pi by 2 minus theta. 3 pi by 2 is the value of 270. 270 minus theta. So my angle is less than 270. That means it comes in which quadrant? Third quadrant. Third quadrant is tan and cot are positive. So cot is there. So value is positive. So tan theta. This is how we are using this ASTC rule to simplify our trigonometric functions and to solve the problems, to convert from one angle to another angle, to simplify the angle, etc. That is with regard to the first point. Second point, if my angles are 0, 180, 360, that is 0, pi, 2 pi, 3 pi, n pi, then such occasion, my trigonometric function will not change. It will remain the same. Sine remains the sine, cos remains as cos, tan remains as tan, secant remains as secant, cosecant remains as cosecant, cot remains as cot. There is no change. For example, Let us take it as cot pi plus theta. So pi is there, so I can take cot as it is cot pi plus theta 180 plus theta. That is, the angle is more than 180. The quadrant is third quadrant. Cot is positive. I can press cot theta. So for same thing, I'll take cot 2 pi plus theta. So what happens? Pi is there, cot remains as cot. Therefore, cot remains as cot. 2 pi means 360. My angle is more than 360. That is, it is again entering to first quadrant. Therefore, the sign remains positive. Therefore, cot theta. So this, please remember these two important points. Basing on these two important points, will be solving a lot of problems, and these two important points will help us to solve many MCQs. Instead of using any formulas, any identities there. If you know this ASTC rule, you can simplify most of the things without using formula over there.
So can you explain once this trigonometric function that 90
This
degrees
is
tan to
okay. So when when the value of the trigonometric function, just a minute. Okay. So whenever my trigonometric function, let us say sine, cos, tan, any trigonometric function, if the values are 5 pi by 2, I'm taking radians because uh, since we are in +1, most of our trigonometric the angles will be given in radians. So I'm avoiding lot of degree measure. So I'll be giving in radians. So when it is pi by 2 or 3 pi by 2 or else 5 pi by 2, if I write generally, if it is 2n plus 1 pi by 2, that is a odd multiple of pi by 2. Pi by 2 is nothing, 90 into 3, 270, 90 into 5, 450 degree. So any trigonometric function coming in contact with pi by 2, don't worry about don't worry about 270 or 450 anything. If you see a pi by 2 in an angle, 2 pi by 2 or 3 pi by 2 or 7 pi by 2, anything you see, the moment you see a pi by 2 in an angle, you have to remember this rule. What is that rule changing? Any trigonometric function having a pi by 2 concept, then the trigonometric function changes. It changes from sine to cos. If it is sine, it will become cos. If it is cos, it will become sine. If it is tan, it will become cot. If it is cot, it will become tan. Let us take some example. Let us say sine pi by 2 minus theta. So now what is happening? Now that my angle is pi by 2 minus theta. So pi by 2 is there. So what I can do, I can change. I have to change. So what happens? Sine becomes cos. And what is the angle left out? The angle left out is theta. So the angle left out is theta. Now I have to decide which sign to put. Whether I have to put plus sign or minus sign. Now I have to, what is called, I have to think which sign I have to put. So coming to this angle, pi by 2 minus theta. Pi by 2 means 90 minus theta. So my angle is less than 90. So where do I get less than 90? The first quadrant. The first quadrant, what is the value of sine? Sine is positive. Therefore, it is plus. Please don't get confused with cos here, because what question is given, that values sign will check in the quadrant. We'll take another example. Let us take it as cosecant of 3 pi by 2 plus theta. So Here pi by 2 is coming again. So what we are supposed to do? We are supposed to change it into another function. So cosecant will become what? Secant. So now what is the angle? Theta. So now I have to check the sign. Which sign I have to put? 3 pi by 2. What is 3 pi by 2? It is 270. 270 plus theta. 270 plus theta means it is more than 270. So my angle is more than 270 means it is in the fourth quadrant. In the fourth quadrant, does my cosecant is positive? No, my cosecant is negative. Therefore, it becomes minus secant theta. We'll take one more example. Let us take it as tan 2 pi minus theta. Tan 2 pi minus theta. So here now pi is coming. So what is the second point telling? If my angle is 0, pi, 2 pi, 3 pi, any value with pi, my trigonometric function will not change. It will remain the same. Since pi is coming, it will not change. It remains the same. So now I want to simplify it. So pi is coming, so tan will remain as tan. Now the angle is theta. I'm writing this as theta. Now I have to see, for example, what is the sine? 2 pi is 360. 360 minus theta means my angle is less than 360. My angle is less than 360. That means which quadrant the tan is coming? The tan is coming to fourth quadrant. So fourth quadrant is tan positive. No, tan is negative. Therefore, I'm putting it as minus 1. Did you understand, dear students? Do you all understand?
Yes, sir.
Shall we proceed ahead? Okay. So far you have learned all these things. Now comes the very important thing. I will learn these formulas, dear students. Trigonometric identities. Not trigonometric identities. This is a, sorry, the topic is wrong. Supposed to be the sum or difference formula or allied angle formulas.
No, sir.
I will learn this formulas, dear students.
No,
If
sir.
no, I will have a, if it is no, then I will teach you a small trick to remember this formula. If you have learned it, no issues. We can just brush up and you can go ahead. Please, one of you unmute and tell me, I will learn this formula, dear students.
No, sir. We didn't learn.
Okay. This is the first time you are seeing these formulas.
Yes, sir.
Okay. No worries, students. So, dear students, to solve this trigonometry, these formulas are very important. Huh? So many say trigonometry is difficult, but if you know these formulas, trigonometry is like a cakewalk. You're walking, it's a easy go. So this formula is called as allied angle formula. Allied angle means combination of two angles. We ally. You have this concept in chemistry, alloy, mixture of two chemicals. Correct, no? A mixing of something with the other. Same thing here, what is happening when we say allied angle means we are mixing the angle. We are having combination of two angles, sine A and sine B, A plus B. So like that, when we have this combination of two angles, we are having certain formulas, maybe addition or subtraction. So this formula is also called as allied angle formula or also sum and difference formula. So I will easily explain to you this concept with our everyday example. Hmm. Though it is a sometimes the example can be a debatable, but it's a general reality. Don't take it very seriously. So before going it here, and since most of you are studied in co-education school, and most of you are into your neighborhood and so on, you have seen this friend circle among boys and girls, isn't it? So there is a friend circle among boys, there is a friend circle among girls. Each friend circle has their own respective way of going through the things. When you say friend circle, there will be a lot of misunderstanding, there will be a lot of fight, all those things are there. That is what a friend circle is there. Means friends will come together, fight, argue, then again they are together. Only then we can say that as a friend circle. Just a minute, sorry. So, what happens in a boys' friend circle? Any fight, or let us say, we'll take one example. Mm, these boys are going, let us say, out for okay. There are five boys. Let us say three of them. Okay, among five of them, two of them, what they did, they in the evening, the last hour, they bunked the class and they went out for maybe a mall or a cafe. One of the friend, what they did, he took some photos and he, without knowing, he posted in Instagram. The other friends came to know, and you know what happens? Some fight and so on, etc. happens. Honestly. Let it be any amount of fight. Maybe this example, any fight happens among boys circle. What happens? They fight. They may not speak for one day. Or the fight may go to a physical fight. But the boy from this friend's gang will not move to another friend's gang. Though they may not be speaking, maybe misunderstanding because of fight, they may say, "Call him, man. Why you can't call? Because I'm not speaking to him. You call him. You text him. You tell him like this." So these things happens, but we don't see any boy, a friend in a boys circle will go from one friends group to another friends group. Coming to girls friends group, okay, there are also a lot of fights are there, etc. and so on. Once one fight happens, within a fraction of second, within few minutes, the girl which is in one friends group is found in the another friends group. I'm telling you general reality. I'm telling not every girl are doing that one. A general reality. So taking this concept of friend circle of boys and girls and putting it here. What happens in boys friend circle? Any amount of fight, misunderstanding. Okay, they may not speak. Sometimes they may come out of the gang, but they will never go to a new gang. Whereas in girls, any small fight or any petty fight, they tend to change from one group to another. Now coming that, I'm applying that concept to your trigonometric function here. Now my cos is like boys. My cos is like boys. If it is in one gang, it will be in the same gang only. Let us see here. I take sine as sine, let us say. I'll change the color. I'll take sine as gang 1 and cos as gang 2. Huh? Friends gang 1, friends gang 2. When I say, I told cos is like boys, so what is happening? When cos is any fight happens, the boys gang stays with only one gang. Let us see here, it is with gang 2. So it is with gang 2. Is there any mixing of gang 1? No. Gang 1 is separately sitting there. Here also, if I take cos of A minus B also here, cos is with gang 2 only. It is, so next gang is there only. There is no mixing of this gang. Even though they speak or they don't speak, they are in the same gang. They don't mix with the other gang. Whereas in sine, you see here, a small fight happened from gang 1. From gang 1, what happened? From gang 1, the girl is moving to gang 2. And again, small fight happened from gang 2, the girl is moving to some other gang 1. So here also, sign, it is in gang 1, some fight happened from, because of the fight, it is moving to gang 2. And again, another small fight happened in another group. From that group, it is coming back to another group. So this is another a small way of remembering the formulas for sin A plus B, sin A minus B, cos A plus B, and cos A minus B. So cos is like boys gang. So it is with only one gang. I mean, it can go with only one gang. It can't mix up. So when I say cos of A plus B means the gang 2 will come first. What is gang 2? Cos A into cos B. Depending upon the formula, you have to fix the sign. Then goes with second gang. What is the second gang? Sin A into sin B. So both the gangs are separate. No boy is mixing with the other gang. No boy from another gang is mixing to this gang. When it comes to sign, whether it is A plus B or A minus B, a small fight happened from gang 1, sign is moving to gang 2. From what is happening? From sign, it is moving to cos. Again, some fight happened from gang 2, it is moving to gang 1. From cos, it is moving to sign. Only we have to know where the sign to put. For which, for A plus B, what sign to put, A minus B, what sign to put. Then comes tan. Okay, sign is like girls, cos is like boys. What is this tan? Tan are like singles. More than singles, I can say it as a single ultra legend pro, because we have seen this type of characters in our life that they never mingle with any others. They are themselves with their mobile into the social media, or not even social media, some watching reels. They tend to speak with themselves. They not even mingle with the family. If anything is there, yes, no, no more than that, speaking and so on. So, like these persons we have come across in our daily life. So, like that character is Tan. For Tan, I am the king of my world. I don't want any others. It's my world. It's me. I am the king. So, the understand this trick to remember the formula. So this is I have thought much more easy. So plus cos into sin from G1 to G2, from G2 to G1. Remember that. One for one guy for other guy. For A plus B is plus, for A minus B is minus. Sign, same thing. What is the for left hand side coming the right hand side? Whereas in cos, if it is plus, the minus will come. If it is minus, the plus will come. So only first gang will be there. That is cos A into cos B. Then sin A into sin B. Whereas tan is a single only E is there. So tan of A plus B is equal to tan A plus tan B whole divided by 1 minus tan A into tan B. For us, as for A minus B, tan A minus tan B whole divided by 1 plus tan A into tan B. So we go to next concept, dear students. Next concept is multiple angles. That is sin 2x. The formula for sin 2x is 2 sin x into cos x is equal to, this also can be expressed as 2 tan x by 1 plus tan square x. There are a lot of derivations since it is matriculation board, okay. In CBSE, we don't derive. That's the reason I'm not deriving the equations. So cos of 2x is equal to cos square x minus sin square x. That also is equal to, okay. Just a minute. Listen, just you go through this sin of a plus b. If you want, you can jot it down in the book, as you can take a screenshot. With this, we'll solve some problems today. The other formulas we'll learn tomorrow. With this, we'll solve some formulas today. Sorry, some problems today. Can I take note of these formulas, dear students? Basing on these formulas and other concepts, we'll solve some problems today. Sin A plus B is equal to sin A into cos B plus cos A into sin B. Sin of A minus B is equal to sin A into cos B minus cos A into sin B. Cos of A plus B is equal to cos A into cos B minus sin A into sin B. Cos of A minus B is equal to cos A into cos B plus sin A into sin B. Tan of A plus B is equal to tan A plus tan B whole divided by 1 minus tan A into tan B. Whereas tan of A minus B is equal to tan A minus tan B whole divided by 1 plus tan A into tan B. Okay, we'll solve the problems. So the first problem is if tan A is equal to 1 by 2 and tan B is equal to 1 by 3, find the value of A plus B. If tan A is equal to 1 by 2 and tan B is equal to 1 by 3, find the value of A plus B. So students, what they're given is they're given us the value of tan A and tan B. Now we have to find the value of the angle. A and B are nothing but angle. So we have to find the value of the angle A plus B. So since they're given tan A and tan B, it is easy. We'll use the formula of A plus B. So what is the formula for tan A plus B? Tan A plus B is equal to tan A into, sorry, tan A plus
Tan B
tan B
by 1 minus
1 minus tan A into tan B. So now we'll substitute what is the value of tan A? Sorry, tan A 1 by 2 plus 1 by 3 whole divided by 1 minus 1 by 2 into 1 by 3. This is equal to how much? Cross multiply. LCM is 6. 3
6.
plus 2 is 5. This will be 1 minus 1 by 6. So this will be 1 minus 1 by 6. So that is equal to how much?
5 by 6.
5 by 6 divided by 5 by 6. This will be is equal to 1. So right hand side, what is my right hand side? Right hand side I have got tan of A plus B is equal to 1. When does we get 1 in tan? When do we get 1 in tan? For what value we get 1 in tan? For what value we get 1 in tan? Students, for which value do we get 1 in tan?
In 90 degree?
No, 90-degree tan is undefined. Tan will not exist.
Okay.
45, sir.
Very good, 45. So we get 1 when tan is 45. Huh? If I write in radians, it is a please try to learn it in radians. I have learned the degree and radians method. Students. So 45 can be written as pi by 4. How we know that 1 degree is equal to pi by 180. So I want 45. So 45. So 45, that means 5 nines are 5 3s are 15. 5 6 are. So 9 ones are again 9 4 are. That is what is the value of 45? 45 is equal to pi by 4. This is how you are simplifying and doing it. So tan get cancels, the value of is tan get cancels. What is plus b value? Is not a plus b is equal to pi by 4. Do you understand this problem? The problem. So we have done the problem. If tan A is equal to 1 by 2, tan B is equal to 1 by 3, then what is the value of A plus B? So we are using this formula. Tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. So tan A value is already given half plus 1 by 3. So just we are putting the values, substituting it, simplifying it, then we are getting the value. Okay, go to the next problem, dear students.
Yes, sir.
Okay. Okay. Before we go to the question number this one, the value this is very easy. Same thing. Same like what we what we did. Students, will you able to solve this question for me? Will you able to do this one? Try it out. So the question is the value of sine 45 plus theta minus cos 45 minus theta. So what you are supposed to do here? Use the formula of plus b. Here formula for cos a minus b. My a value is here how much? My a value is 45. My b value is theta. The students, will you solve or do I need to solve for you? Students,
Yes, sir. We'll try.
please try. If you are finding difficult, let us know. We will solve it together. Using the formula, first add the formula, substitute the value, then sin 45 has got a value.
Your answer is 1 half. 1.
Answer is what, my dear friend?
Sir,
Answer is
sin
1. No, no,
a plus.
no.
Hmm.
Answer is 1 is wrong.
Sir, is that 0?
As 0. Don't worry, we'll try it out. So don't worry. So we are using the formula. What is the formula for sin of a plus b? Sin a, that is sin 45 into cos B theta minus, sorry, plus cos, what is called, cos 45 into sin theta. This is for first part. Minus. So the minus, I am taking minus inside is, now I am skipping one step. I'm taking minus inside. So what happens? So it will happen, it will become what? That is equal to minus cos of A minus B means cos 45 into cos theta plus into minus will become again minus sin 45 into cos theta. See, this one and this one is getting cancelled. Plus sin 45 into cos theta minus sin 45 into cos theta is getting cancelled. So what we are left out is cos 45 into sin theta. What is the value of cos 45? 1 by root 2 into sin theta minus cos 45 is 1 by root 2 into cos theta. Sorry. I have gone wrong here. Sorry, extremely sorry. The formula supposed to be sin. This is sin theta. So nothing will cancel. It will be so it is sin A into sin B. That is sin theta only. Extremely sorry, dear students. This is sin theta. So we have to substitute the value for all the angles now. Sin 45 is 1 by root 2 into cos theta plus cos 45 is 1 by root 2 into sin theta. So minus cos 45 is equal to 1 by root 2 cos theta minus sin 45 is 1 by root 2 into sin theta. We don't know the value, we are writing as it is. See, 1 by root 2 cos theta plus and minus is getting cancelled. Again, 1 by root 2 plus sin theta and 1 by root 2 minus sin theta is getting cancelled. So what we left out? We left out with the answer called 0. So what is the value for this question? The value is 0 when the value of sin 45 plus theta minus cos 45 minus theta is 0. So next problem. I'm trying of same. I have taken another question of same type. I'm saying where that question is. Okay, don't worry. We'll take one question. The value of sine phi theta minus, okay, sine, okay, this question is already there, I think so. Sine 70 theta plus sine tan theta. You may be wondering, sir, we don't know the values of anything, 50, 70, 10. How to do? I'll give you a clue. We can convert into standard angle and something, that is sine 60 minus 10 minus sine 60 plus 10, then plus sine 10. Now this is like the previous question. Will you try out, dear students? Please try to solve and tell me the answer, what answer you are getting it. Okay, students, we can take this question as a homework. We will learn what is called. We'll discuss the same problem tomorrow. What answer we'll get. And one thing with that, I will request you, dear students, to go to this. Yes, somebody told something.
Sir, the answer is
Yes.
2.
No, sorry, wrong answer.
Sir, is it sine 10?
No. Same. So, yes, my request to you is tomorrow when you come, please learn the six for what the summer difference for us. With that, please go through this formula of multiple angle. What I am displaying on the screen. Don't worry, I will be sending this thing as a PDF to the sir, and sir will be forwarding to you. So this is multiple angle, this formula. This formula. Just go through it. I'll be explaining it tomorrow with some like this one trick I'll be giving to you. So with that trick, you'll be able to easily understand and you can learn the formula. But you can once you go through it, and it will be easier for you. So kindly go through this things and come, dear students, and try once again. Once you go on home, so I'll discuss that question tomorrow.
Okay, sir.
Can you come, ma'am?
Yes, sir. Yes, sir. Thank you,
It's
sir.
time for me for my college. So I'll be. Thank you, sir.
Sorry, sir.
It's time for my college. So I'll be logging out.
You want to know about the details of the college timings of students?
No, I have got already time for my college. 7:30 is my check-in time. So I'll be logging it out, I told you.
Okay, sir.
Okay. Thank you, ma'am.
Okay, sir. Thank you, sir. Yes, students, again we will meet evening from 7 to 9. Bye, everyone.